Hi, we are going to model this equation 3y plus 2 equals 5y. Now this is an equation with variables on both sides. It might seem confusing, but we're going to first try to model this equation before we solve it using the algebraic way. We need to symbolize each of the elements of this equation. So let's look, take a closer look. How many elements are there? So I see a constant term. Actually, this is a coefficient. So I see a constant term. I see a variable. Are there any more kind slash types of numbers over here, such as like an imaginary number or something? No, I didn't see any. So therefore we know that I am going to symbolize a variable, which is y in this case, and a constant, which are numbers using the ones. So I'm going to symbolize them. So I am going to represent the y's using this pinkish triangle over here, and the ones using this purple circle. Okay. So I'm going to. So that means for each y, it is a triangle like this, and for each ones, it is a circle like this. So let me demonstrate this to make this more clear. So now first we work out the 3y. 3y means I got 3 of the y, so I'm going to draw 3 of the triangles. Well, it makes sense because once we cover up these two y's, we got one y. So 1y times 3 is 3y, so we got 3 of the y triangles. It makes sense. Now we work out the 2. So the 2 is basically 2 purple circles because we can represent it as 2 ones because 1 plus 1 is 2, and each circle represents 1. So 1 plus 1 is equal to 2. Okay, so we draw 2 purple circles here. You don't really have to use these purple circles and pink triangles, but this is just one way of modeling. Okay, so it is equal to 5y. Therefore, I'm going to draw 5 of the y triangles, or the pink triangles. 1, 2, 3, 4, 5. Yes, I did correctly. So this statement states that 3 y's plus 2 of the ones is equal to 5 of the y's. Now we are going to try to cancel out some of the like terms slash constants from both sides of the equation. So because let's look at this example to make it clear. Let's say 3 plus 2 is equal to 3. We can basically cancel out the 3's, right? Because 3 is equal to 3, so we don't really have to work out with something. Let's say 3 times 4 equals 3 times 2. No, we can't cancel out these 3. Okay, so because we don't really need them. So I am going to try to find pairs from both sides to cancel out. So I see a pair of triangles. No, I see 3 pairs of triangles. So I see 3 triangles over here and 3 triangles over there. So this means that I am going to take all of them out, since these two are equal to each other. So we just cancel them out. So now we left off with 2 of the ones. We represented with 2 of the purple circles is equal to 2 of the y triangles, which are those pink triangles, because we cancel out these 3 triangles from both sides. Now, this statement shows that 2 of the ones is equal to 2 of the y's. Now, what does 1 of the ones equal to? What does 1 of the y equal to? Remember, when we're solving an equation, we're trying to solve for the variable. So we are trying to solve for the variable y, which we're trying to get 1 of the y's over there. So to do this, I am going to divide both sides. I am going to divide. Okay, so now I'm going to divide this side by 2 triangles. Since I know that 2 triangles is equal to 2 circles, so that I can divide 2 circles over here. So 2 triangles divided by 2 triangles is simply 1 triangle. So we can write 1 triangle over here, and it is equal to 2 circles divided by 2 circles. It's just 1 circle. So therefore we know that the variable y is equal to 1. Now, if you don't believe it, you can substitute the value of the variable into the equation and check it. So 3y is 3 times 1. 3 plus 2 is 5. 5 equals 5 times 1 is 5. So therefore, y equals 1 is a solution of the equation. So I am going to highlight this answer, and this is the final answer, y is equal to 1, for this equation with variables on both sides.